Hi folks, we come to the part 3 video of the exercise 7.4 and we were continuing with the application problems on combinations. We will take up the 6th problem, and 6th problem says that determine the number of 5 card combinations out of the deck of 52 cards if there is exactly one ace in each combination. You have to pick up 5 cards out of the 52 cards with the condition that it has to have exactly one ace. So no matter how you choose your cards, but it should have one ace. The remaining 4 cards can be anyhow, it can be anything other than the ace, but that one card has to be ace. So it's basically like this, that we are actually selecting these 1 2 3 1 2 3 4, and this has to be ace, and this can be anything else. So what can it be? It can be non-ace, any non-ace cards. So it is like you are selecting 4 non-ace cards and you are selecting 1 ace card. So the numbers to be selected is clear. Now we have to find out from how many can we select this. In the pack of cards, we all know that there are 4 aces. Yeah, so therefore how many choices we have? We have a choice of 4 aces. So if you have 4 aces, how many non-aces do we have? In a pack of cards where there are 52 cards, if 4 cards are aces, automatically the remaining are non-aces. That means 48 non-ace cards are there. So we are having 48 non-ace cards. So that's all. That is going to be our logic. We are going to select 4 non-ace from 48 and we are going to select 1 ace from 4. Multiplied together, that will be the required 5 card combination for us. I hope it's clear. One card, because it has to be ace, we make its selection, then remaining it's a non-ace, so we make a selection and then we multiply it to get the total number. So let's write it here. The one ace has to be selected from the 4 aces in the pack or in the deck. Therefore, number of ways of doing it. C1. Also, 4 non-ace cards have to be chosen or selected from 48 non-ace cards. Number of ways of doing it. C4. Okay, so therefore the required 5 card combination. One work done in m ways, the other work done in n ways. Total number of ways of doing it is m into n. So 4C1 into 48C4. Okay. Literally you put up the values. Also NC1 is always n. We'll see it how. 4 factorial by 1 factorial into 3 factorial by formula, but 3 factorial into 4 like that. So 48 factorial, 4 factorial, 48 minus 4, 44 factorial. This is a big deal. Oh, if we cut this also, I don't know, well, it should be better put 4 here, because it's like 3 factorial into 4, 3 factorial cut 4. Okay, and this is like 44 factorial into 45 into 46 into 47 into 48, and 4 is 2 into 3 into 4 factorial. So, and 44 factorial, of course, that will get cut. Then the 4 and 4 can get cut. The 6 can cut with 48. Oh, now we have to multiply the remaining. 46 into 47. 6 sevens are 42, 28, 32. 6 fours are 24, 4 fours are 16, 18. So 2, 6, 11, 2, 1, 6, 2. Not over. You have to multiply. We'll do one thing. 45 into 8, maybe it will give you a simpler value. Let's multiply 45 into 8 and check what comes. 8 5s are 40, 32, 36. So then we can multiply by 36 and just take the 0 added up. 6 2s are 12, 36, 37, 6 9, 6 2s are 12, and then 0. 3 2s are 6, 6 3s are 18, 4, 3 2s are 6. Let's have this added up. Space shortage. 2, 13, 9 and 9, 18, 6 and 1, 7, 7. 7, 7, 8, 3, 2 and 1 0 of this one. 7, 7, 8, 3, 2, 0. Such a complicated number. So many ways of getting the 5-card combination. Okay, when we have to have one ace there. This is how we go about doing that problem. Now we are taking the next question, 7th one. Let's see what the 7th one says. It says that in how many ways can we select, I hope you looked at the word, select a cricket team of 11 from 17 players. You've got 17 players. From there you have to select 11. If the question didn't have anything, okay, if the question had only this much part, select a cricket team of 11 from 17. What we will do? We will do 17 C's 11. But here that's not the case. They give us restrictions. So let's see what's the restriction. It says that in which 5 players can bowl, and if each cricket team of 11 must include 4 players. So now this 17 players have got only 5 people who can bowl, and from that 5 people you have to select 4 people, like the ace problem only. You have to select the 4 people. You have to have bowlers there. Okay, it's very confusing. So let's divide this. See, these 17 players that they say, actually because they are 17 players, but they have a prescription like how we did here, ace, non-ace. So like that, bowlers, non-bowlers. They want 4 bowlers exactly, and non-bowlers, they want remaining have to be non-bowlers because there are 11 people. We have 7 more people to choose. So 7 more people to choose. Okay, so the choice part is clear, but how much to choose from is not clear. So let's see. Bowlers, how many choices do we have? Yes, for bowlers we have a choice of 5 bowlers. And for non-bowlers, how much do we have a choice? 17 people are there, out of which 5 are bowlers. So remaining are non-bowlers. So 17 minus 5, 12 non-bowlers, right? Non-bowlers are 17 minus 5, that is 12. So in order to get this number, it is 5C4 into 12C7 multiply m base n base. Let's see now. The 4 bowlers can be selected from 5 bowlers in have to be, right? We will not change the style, you know, it becomes very confusing for beginners. Have to be selected from the 5 bowlers. Therefore, number of ways of doing this is 5C4. Also, 7 non-bowlers have to be selected from 17 minus 5, that is 12 non-bowlers. So, number of ways of doing this is 12C5, sorry, 12C7. M base, N base, as I said. Therefore, number of ways of choosing the team of selecting the team is 12C7 into 5C4. Let's have it. 12 factorial, 7 factorial, 12 minus 5, 12 minus 7, 5, 5 factorial. NC n minus 1 is also n always. We'll take that. Always remember, NC n minus 1 is n, NC1 is n. So that is, but why unnecessarily use the property always? So it is NC n minus 1, it's 5. Here, this is 7 factorial into 8 into 9 into 10 into 11 into 12 and here 5 factorial is 2 into 3 into 4 into 5, 1 is also there, into 7 factorial, not to forget. Right, now what all things can go? 5 2s are 10 can go, and 4 3s are 12 can go. So we are left with 8 into 9, that is 729 in, 72 into 11. So let's check some place. 72 into 11. 11 2s are 22, to carry 11, 77, 79, 792. Do we have any zeros? No. So 792 ways you are able to no. There is a 5 also. This 5 into 5. Let's check. 5 2s are 10, 9 5s are 45, 46, 35, 39. Yes, so many ways. 3960 ways you can choose this cricket team. That's about the 7th question. We can quickly move to the 8th and see what it says. It says that a bag contains, that's easy. That's easy. We have done a problem like this. A bag contains 5 black, 6 red. It's there. Determine the number of ways in which 2 black and 3 red balls can be selected. Yeah, a bag has got already 5 black and 6 red, and from there you have to choose 2 black and 3 red balls. We have done that. So here we need to choose. We need to, let me look at the word, number of ways in which selected. We need to select 2 black, was it, or blue? 2 black and 3 red balls from 5 black and 6 red balls. If a number of ways of doing this, is 5C2, 6C3. Yes, and total number of ways of selections of the selection is 5C2 into 6C3. Let's quickly do it. 5 factorial, 2 factorial, 3 factorial, 6 factorial, 3 factorial, 3 factorial. And this could be 3 factorial into 4 into 5. 2 factorial is 2 itself. 3 factorial into 4 into 5 into 6, and 2 into 3. So 3 factorial is also there. So cancel, 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 and then 6 can get cut, 2 can get cut, 20 and 10, 200 again. Yeah, somewhere we got 2000 or something. Yeah, 200. This can be done in 200 ways. Simple. We have done that earlier. Let's take the 9th one. That is also a simple problem. It says that in how many ways can a student choose? Please look at this word also. These are the things that are going to be useful to you when you have to distinguish in the exam. Choose a program of 5 courses if 9 courses are available, and suppose say the question has only its first part, that so in how many ways can a student choose 5 courses out of the 9 courses? In how many ways do we do it? 9 say 5. That's easy. But here they put a clause and they say that if 2 specific courses are compulsory for every student. So there is some 2 course which is compulsory for every student, like we have in our 11th standard, English and some of the other electives they have Hindi or some seconds. So that is compulsory, that everybody has to select. So there's no choice. From the remaining you can have choice. So like that 2 courses are compulsory. See, when something is compulsory, your choice is reduced. You don't have 9 courses to choose. Though there are 9 courses in paper, you cannot choose from the 9 course. You can only choose from the 7 course. Why? Because 2 is compulsory. You have to take it. So it's out of your choice. So you've got only 7 things to choose from. right? And because 2 is compulsory, you are actually not choosing 5 courses, you are choosing only 3 courses, because that 2 is compulsory, you have to have it, right? So there's no point of choosing it at all. So it goes out of your arena of choice. So actually in practice, you're not choosing 5 courses out of the 9 courses, but you're choosing 7 courses out of the you're choosing 3 courses out of the 7 courses, right? This is the point of compulsory. Now the same question can be restructured with different digits or different numbers, but this is the idea that you have to keep in mind. Whenever there is a compulsory factor coming, that factor will reduce both from the choice and from the selection. So both places the choice has to get reduced. Okay, so let's come back to this problem and see what it says. Since 2 courses are compulsory, we have only 7 courses to choose from. Also, 5 courses is reduced to 3 courses. As the other 2 are compulsory. I mean, there's nothing like a choice there, right? So therefore, number of ways of choosing this program or whatever. What is this? Program, yeah. Choosing this program is from 7, you are making a choice of 3 courses. That's all. Because what that compulsory thing has to reduce from both the places. That's all. So it will come to 7 factorial by 3 factorial. 7 minus 3, 4 factorial. On solving, 4 factorial into 5, 6, 7. And 3 factorial is 2 into 3. 4 factorial is there, which is getting cut. So you have 6 getting cut, 35. There are still 35 different ways in which you can make the choice. That is about our problem number 9, and we finish our part 3 video over here. In the next video, we are coming with the miscellaneous exercise. Thank you.